Hello, my name is Jose Higuera.
My name is Bruno Matsui.
I am Harsh Pathak.
And we did project 1, the commodities market.
And today we will be showing you a little bit of our documentation and how the GUI works. This is Jose Higuera, and I am going to be presenting the GUIs. The first GUI that we have is it's called prompt 1. It's the very first thing that the user will see, and basically it has a pop-up menu with two items, either the commodity price index or the individual commodity prices. Either one will take you to a next screen, as you will see. And from there, it gives you, these are the individual commodity prices. Here you can choose from a list of the commodity prices. Once you click on one, it will give you a starting date of the prices and the last date of the prices available. Now, right next to the window pops up another menu, which allows you to choose the method of graphing that you would want. You could choose to plot a month every year. You could choose to plot a range of years where the user would enter an input. You could choose to chart quarterly bar charts for the entirety of the data available, or you could do a bar chart over the range of years.
My name is Harsh Pathak, and today I'll be presenting the GUI for our program called Commodity Analyzer. So here, this is our function, and we're going to run this file to create our GUI. So I'm going to press the run button, and our GUI pops up. So this is the first screen the user will see when they enter our GUI, and there are two options, and as we're going to select on this menu. And so we have the option of looking at commodity price indexes and individual commodity prices itself. So in this case, we'll just click on commodity price indexes. And this brings us to a second figure. And we'll take a look at this case. The user has options of looking at various indexes, including food, beverage, agricultural, metals, and fuel index. So we'll select on food and beverage price index. And the user is given a reference of which prices they have access to. So in this case, they have access to from May 1991 to February 2015. So, and then in this case, the user has four options for graphing. They can plot a month every year. They can plot a range of years. They can make a quarterly bar chart, or they can make a bar chart over a range of years. So we'll try quarterly bar chart. So here's the quarterly bar chart for non-fuel price index on the interval of every 3 months from 1991 to 2015. Now we'll go back to the GUI, run it again. This time we'll try the individual commodity prices. This brings us up to comparing individual commodities that we would like to see. So the user can select from all these commodities. So we're going to choose cotton. And the prices are available from May 1980 to February 2015. So we'll make a bar chart over a range of years this time. And we'll say, show me the bar chart. But before that, we need to enter the starting year and ending year. So we'll go from 1996 to 2014. Show me the bar. There it is. The bar chart for cotton on the interval of every 12 months from 1996 to 2014. Hi, my name is Harsh Pathak, and we'll be talking about task 11 today. In this task, main purpose is to query the internet and use regular expressions to get the current data from the Wall Street Journal. So we created a function, and we're going to call it getCurrentData, and we're using a switch case structure. So the first thing we do is we read the URL, and we save it to the variable journal. And After this, we convert it. All the text in the URL is converted to a string, and basically we have indexed the prices and put them all in a cell. And the final cell contains all the current prices of the individual commodities. And that's essentially it. And so the 4 commodities we are comparing are copper, high grade, aluminum, cotton, and cocoa, Ivory Coast beans.
So this function is called data bar. It creates the bar graphs for the data that you select. So we use a data set and the tags and the particular commodity ID, the year 1, the year 2, and the resolution we want to go with. This part, we calculate the starting and end position using, the years and the months that we are given. We get the particular data we're going to be using the data ID tag, and we're going to go to the end of all the data. So here's this loop that allows us to do the plotting of the bar graphs. We get this function here called bplot, which was created by a coder some time ago, and it basically creates a box and whisker plot for a set of data. So we create multiple box and whisker plots for every resolution step until the end of iData, basically creating a bar graph.
Inside the code of the individual commodities, there's 2 functions called by prompt 1. There's the individual commodities and the indexes. The indexes is very similar, but the individual commodities one has a little bit more coding in it. At the very start, we're importing the data, and we're attaching it to the handles structure in order to be able to access the data later on. And then later on, under the pop-up menu, we are seeing the value. The value gets added by 10 because there are 10 indexes, so the value on this will be slightly shifted down, but we have readjusted for that. And then we use data to find the dates, and we select and show the starting date and the end date for the commodity that was chosen. There's a graph, or there's a menu that allows you to choose which type of graph you want that pops up. And then after that, depending on which type of menu you choose, we have code for the menu. And then from that, there's the graph month function. Then there's another one, the case 2, which is to plot a range of years, which has to open another GUI interface, choose dates, in order for the user to input their data and dates that they want. And that also includes functions to compute the data that needs to be displayed. There's the data bar, which plots a bar chart. And then case 4, again, must create S for another GUI, choose bar dates, and there the user enters in their values that they want. Again, there is a switch case here, and these are to only apply to the special cases such as cotton and copper, and they allow you to see and chart prediction of an EMA price.
It's a function that will take the Excel data from this location here. It'll write that into a temporary Excel spreadsheet. We get the date and the clock, and that will help us find where we're going to end the range of the read. So it'll read from B5 all the way to BL 426, which is the output of this. And it's interesting because it'll update monthly because we're using clock, so all the information will be up to date even if it's 2016 or something like that. These are a few sections here that were generated by MATLAB so that we take all the tags of this data, which were in the first four rows, and we put them in a cell matrix.